Alright, hello everyone, this is KP the Math G, and for some of you who have seen me, some 145 times, or whether you've seen me 30 times, or 20 times, or 10 times, whatever, you know that I've been away for a while from doing this. One grandchild has already arrived. Okay, from my daughter's side. I didn't think she'll ever have a grandchild, but she did. Being married 10 years and now a grandchild. Wonderful boy, little boy, beautiful little boy. And then my son is expecting his second child, so another grandchild for my wife and I. So needless to say, we've been busy and traveling. It's been my birthday, so we've done some traveling over the time, and it's been a little while. Anyway, I'm back. Okay, KP the Math G is back. We're going to look at a question from 2019, the free response question 6. Now, let's pay attention to something here. Functions f, g, and h are twice differentiable. Now, let's stop right there for a second. Twice differentiable. If they're differentiable at all, what do you know about the curve or the line or whatever the graph is? What do you know about it? Yes, if you said that it is continuous, absolutely. Everything that is differentiable, every graph that is differentiable, every function that is differentiable is also continuous. The graph of it is continuous. But not everything that is continuous is differentiable. Okay? So be aware of that as well. But every function that is differentiable is continuous. All right, keep that in mind. And we got functions with g at 2 equals h at 2 equals 4. So both of these are equal to 4, and the line is y equals 4 plus 2/3. Well, why did I box in 2/3? Does anybody know? Well, I wish I could hear through the video, but if I had to hear anything, I would think you would know that that's the slope of this line. So this slope is tangent to this, whatever, okay, to the graphs of g and h at x equals 2. So they're just tangent to both of these graphs. We don't even know what the graphs look like. Isn't that sad? We don't know, and yet they're asking us right off the bat to find h prime. That means find a derivative of h prime at 2. What is the derivative of that? Well, we know that this slope here is equal to 2/3. Okay, so let me just say something here. H at 2, or h prime at 2, this represents the slope at x equals 2 is equal to the slope of the tangent line to its curve. Tangent line given curve, if you want to say that, or just curve. Alright, you remember how that sometimes when you did an x and y like this, you had some kind of line or some kind of curve, maybe like this, and you had a slope. Of course, this will be a negative slope, all right, like this. And of course, you had a secant line, and then of course, as you were learning limit, you know, the point there, this point here of tangency is the same. This slope is equal to the slope of the tangent, the slope of the secant line is equal to the slope of the tangent line, isn't it? Okay, so anyway, eventually they come together, all right? So anyway, that is something that you learn right off the bat when you are learning about slope and so on. So understand then, therefore h prime at 2 is equal to this slope here. Alright, that's all it can be. Right, it's kind of a no-brainer type situation right here. Okay, so that's really all you can say about that one. Okay, that's a really neat little, it should be easy to answer when you look at the slope of this and kind of understand that, okay, we're not worried about h at 2, we're looking at h prime at 2. What's the slope of that at this point here? This point is actually 2 comma 4, isn't it? So at 2 comma 4, what is the slope of this? It's 2/3. Okay, right here is the giveaway here. Alright, let's look at B. Give me time to erase and I will put up the problem. I probably should have had it written down already, but we'll go ahead and write this one down. Okay, let's take a look at it. Yes, okay, let A, okay, now here we go. B part is let A be the function. Be the function, okay? Bear with me, please. I'm sorry, I should have had this up already. So this is A at x is equal to 3x cubed, is it cubed, times, might as well put that little times symbol there, even though they don't put it there, it is understood to be times. Alright, then it says write an expression, again bear with me please, for a prime at x. So first of all we want to find the derivative, don't we? Alright, I'll explain that in just a moment. And then find a prime at 2. Well, alright. We got to find the derivative of this. What, when you first, those of you who are just starting out, maybe you're far enough along. I know that when you start out, you probably likely started with limits, unless that has changed. You started out with limits, and then you're going from the limit to the rules or properties of the derivative, of different types of derivative. And did you not talk about the product rule? Now, don't you have a power rule, and a product rule, and a quotient rule? And of course there's others later down the road called L'Hopital's rule. That's totally different in a way, but still it has to do with derivatives. And that's actually on this test, part C, but we're not going to worry about C at this point. So let's find a prime at x, okay? Let's see here. We'll use a different color here. So a prime at x. Alright, now let's see. The derivative of the, well, we can do the first. If you want to, just rewrite the first part down. Okay, 3x cubed times the derivative of the second, which is h prime at x, right? Whatever this is. And when you see something like this, students, you just have an h of x. Well, the derivative of h of x is h prime at x. The derivative of h prime at x is h double prime at x. And so on. Okay? Alright, so plus the second, which is just plain h at x, times the derivative of the first, which is 9x squared. That's just the power rule, isn't it? So a combination of power rule here and the product rule here. Could I have just wrote down, instead of saying, let's see, wait a minute, yeah, I could have done this first, okay, or the derivative of the first times the second, just doing it backwards, plus the derivative of the second times the first, okay. All right, now that's the first part. Probably you get a point for that, just doing that part. But now what we need to do is find, well, what is a prime at 2? Well, obviously we're going to plug in 2 everywhere there's an x. So here we go. This is 3 times 2 cubed times h prime at 2, which, by the way, we found that out from the last problem, didn't we? From right here. All right. So remember, recall that h prime at 2 is equal to 2/3. We just want to kind of keep a mental note there, don't we? All right, we know that h at 2, we know what that is. H at 2, but I will write that down. So h at 2 is equal to 4. Aye, that's nice. Now then, 9 times 2 squared. Now at this level, please, for either one of these, don't multiply 3 times 2. Do that. You're in calculus now. Don't do that. Order of operations. 2 cubed is 8. 3 times 8 is 24 times h prime at 2, which is 2/3. 2/3 plus h at 2 is 4. Now times, again, not 18 squared. That's a big, no, don't do that. 2 squared is 4. 9 times 4 is 36. You know what? I'm probably speaking to the choir. You already know not to do that. You already know not to come at this level and start doing silly things like that, right? Okay. All right. Good. Well, let's see. What is 2/3 of 24? Well, let's see. I can do this. 3 goes in 24 8 times, and 8 times 2 is equal to 16. Okay, plus. Okay. 4 times 36. I did that right, didn't I? Okay, yeah, okay. So let's see. 4 times 6 is 24. And then 4 times 3 is 12. 144. It looks good. So let's see. 6 and 4 is 10. Carry 1. 1 plus 4 is 5, and 1 is 6. And that is 160, as it should be. Okay. Now, there again, this should be fundamental stuff here by now. Maybe this opened your eyes to other similar problems like this, and you look at this, you say, oh, I don't know how to do it. And I tell you, when I first look at something like this, okay, what can I get out of this? Well, the first A part, I got that tangent line right. Tangent, h prime is going to be 2/3. Okay, I already got that one. This one right here, just remember the product rule. Okay. And then from there, remember now, A prime at 2, plug 2 in, find the answer, and you got it. Okay? Well, that's really all I want to show at this time, because I've been wanting to make my videos a little bit shorter. Sometimes I carry on too long, and you might get, a 30-minute video is pretty long, and some of my videos are right at 30 minutes, and So I'm trying to keep them down to a minimum, but I'm trying to explain them in such a way, hopefully you understand, oh, this is not that bad after all. And that's what I want you to get to, a point where you can look at this and kind of, yeah, take a deep breath. Yeah, don't lose your composure. Just take a deep breath and say, okay, A part, I got this. I already know what this is. This is given to me. Thank goodness it is, right? And then now, just, oh, product rule. I see that this is a product rule. I didn't have that there, did they? This is a product rule. Okay. So anyway, there it is. Well, as the sign says on my, or initials say on my cap, this is KP the Math G signing off. And I don't know if you still remember, those of you who have seen me before, but I always do a final clap, you know. That's my signature clap. Okay, so signing off. Now, here again, this will be my 146th video. I would like for you to subscribe if you want to. I would like for you to make a comment if you would like to. So if you like to do that, and even if you like to express, hey, I need some tutoring, let me know in the comment section that I need tutoring on this, and tell me what kind of problem that I need to put up there, and I will put it up for you, okay? And I will help you in every way that I can. All right, anyway, and then again, if you don't subscribe, okay, this is what, it's not about me getting glory, it's about you understanding how to do this. KP the Math G is signing off at this point. Ladies and gentlemen, students, teachers, have a great, great day.